Right now, a small piece of silicon sitting in a server far away just helped write a sentence, generate an image, or answer a question for someone on the other side of the planet. You've probably never thought about it, but this chip is quietly becoming the most important object on Earth. And the story of how it got there is far stranger than you think. For decades, computer chips were built for one job, crunching numbers one after another in a straight line, fast but narrow. Then AI researchers needed something different. Not one calculation at a time, but millions at once, side by side. A chip already existed for that. It just wasn't built for AI at all. It was built for video games. Graphics cards were designed to render thousands of pixels simultaneously. In 2012, a researcher named Krizhevsky, working with Geoffrey Hinton at the University of Toronto, pointed gaming chips at a different problem: image recognition. The result, AlexNet, crushed every previous record. It ran on graphics cards built for teenagers playing video games. That moment changed everything, and one company had been building these chips for years, almost by accident, perfectly positioned for what was coming: NVIDIA. Founded by Jensen Huang in 1993, NVIDIA spent 2 decades focused on gaming, but after AlexNet, researchers everywhere started buying NVIDIA's chips, not to play games, but to train neural networks. NVIDIA noticed. It decided to become an AI company that also made gaming chips. Here's where it gets stranger. Chip design takes years. So when NVIDIA built chips for AI workloads, generative AI didn't even exist yet. It was betting on a future it couldn't see. That bet paid off. When OpenAI released its large language models, companies racing to build their own needed these chips by the tens of thousands, wired together in massive data centers, working on the same problem for months at a time. Why does this matter to you? Every time you ask an AI chatbot a question, or your phone enhances a photo, one of these chips did the work. Microsoft, Google, Meta, and Amazon now spend tens of billions of dollars every year on these chips and the data centers that house them. New power plants are being proposed just to power them. A chip built for video game graphics is now shaping energy policy, but making these chips isn't simple. The most advanced ones contain tens of billions of transistors, each smaller than a virus. To create them, manufacturers use extreme ultraviolet lithography, generating light by vaporizing molten tin with lasers thousands of times per second inside a vacuum chamber. Only one company makes machines capable of this: ASML in the Netherlands, and only a handful of factories, mainly run by TSMC in Taiwan, can use these machines at the scale AI demands. This is the hidden bottleneck behind the AI boom. Not algorithms, not data. Whether physical chips can be built fast enough by a tiny number of facilities using machines that took decades to develop. A 2023 Stanford AI Index report highlighted just how concentrated advanced chip manufacturing has become, with a small number of facilities producing the vast majority of the world's supply. A delay at one factory can ripple through the entire AI industry. So what happens next? Countries are racing to control the entire chip supply chain. The United States, the European Union, and nations across Asia have launched massive investments in new factories, from Arizona to Japan to Germany. Whoever controls advanced chip manufacturing controls the pace of the AI revolution itself. Meanwhile, NVIDIA keeps rethinking how chips communicate, share memory, and work together as single systems rather than separate parts. And demand isn't slowing. Every new AI model increases the need for more of these chips. Orders once measured in thousands are now measured in hundreds of thousands. There's something almost poetic about how this started. A chip designed to make a dragon look realistic on your screen became the foundation for technology that writes essays, diagnoses diseases, and designs new drugs. Nobody planned it. It emerged from a collision between gaming, research, and a company willing to bet on a future it couldn't fully see. So the next time you ask an AI a question, remember what's happening. A piece of silicon smaller than your hand, built using machines that manufacture light itself, working alongside thousands of identical chips, is quietly doing the work. A chip that started rendering video games is now rendering the future, and it's already inside the phone in your pocket.